Exponential function has to do with either growth or decay. And my hand motion suggests that. And when I say growth, I don't mean a steady growth. I mean in which it's the growth rate in which it just jumps really fast at some point, and then decaying, it topples down really quickly, right? Instead of gradual decline. So we intuitively we know that there are situations like this in real life. That's why these things are so useful for scientists, engineers, for policymakers to understand functions like this, so that we can either make predictions or and have and those of you who have a global study with me, if we can make predictions at a much accurate level, then we can make better policy, right? That will improve our lives. So the biggest thing that we all are encountering right now is COVID. So I'll give you one example from real life COVID data. Okay, so there's one COVID data, COVID infection. Data one, and I'm just going to give you two things, T and N. N is number of infection, T is time, number of days. So day one or zeroth day, you got one person who's infected, and then after 20 days, we got 256 people infected. And we know that infection are growing in an exponential pattern, right? Exponential pattern. So this is data one. Later on, I'm going to give you data two in the same way, and then just help you be able to walk through this. So we know that in our original form of exponential function, we have y is equal to a times b to the x as a general model, general form. In this case, we can replace the variable. We can call this n is equal to a times b to the t power, right? It's exactly the same function, just using different variables. So the question here, right? The big question is find the particular equation for infection. Now, if we can come up with a particular equation for infection, that means that we can make predictions, right? If we say, okay, we know that day one is one person, day 20th, we have 256 people infected by COVID, then the question is, what is day 40th, right? 40 days later, how many people will be infected? If we can make that prediction, we may be able to make better decisions, right? Right now we have all these conversations about masks and vaccines, indoor, outdoor, airplane, whatever, right? We can't make those decisions just because we pull things out of our hats or by the seat of our pants, about whatever. We have to be able to have data-driven decisions. So the question then here is, how do we figure this out? Now, finding a particular equation, this is a general equation. Particular equation means that we need to be able to know what A is and what B is. Yeah? So go ahead and find A and B based on this. I'll give you 3 minutes to figure this out. You don't need to find N because N is a variable, because we're looking for equations. The equation needs to have variable. We don't need to figure out what N is. We don't need to figure out what T is. What we need to figure out is what A and B are for this particular equation. But we have two unknowns. Fortunately, we have two data sets. We have one T value corresponding a one N value, another T value, another N value. with two sets of values, with two unknowns, we'll probably be able to find the two unknowns, right? So go ahead and find A and B. Ready? Now, n is equal to A times B to the t power. We have two sets of data. You take one set of data first, this one, right? So that means t is equal to 0 when n is equal to 1. So you put these two numbers into this equation. So put 1 into n is 1. We don't know what A is, so we write A. Jack, look at it over here. B, we don't know what B is, so we write B. Do we know what T is? T in this case is 0, so yes. So then we say, okay, now what? What would this lead us? Well, 1 is still 1, A is still A, B to the 0 is 1, so A times 1 is A. So that means A is 1. Okay, now I found A. So I will go ahead and modify the general equation, write it down, n is equal to, now in this case, I have a value for A now, A is equal to 1. I still don't have a value for B, so I write down B, and I write down T. Since I already used this set of data, the next available data for us to use is this one. T is equal to 20 when n is equal to 256. So now, instead of going back all the way to this equation, we use the modified equation because we already found A. So now, n is equal to 256, 1 is equal to 1, B is still equal to B, T is 20. So now I clean this up a little bit. 256 is equal to B to the 20 power. Now I need to solve for B. If B to the 20th power is 256, then that means B is 256 to the 1/20th power. Right? So if I use the equation, or if I use the calculator, Do you know how to use a calculator? What's the answer? 1.31. There'll probably be some decimal, right? Yeah. 1.319 or something like that. 1.319 ... Okay, so now I got A, I got B. So my final equation, n is equal to A is equal to 1, has B, I'll put parentheses here, 1.319 ... to the t power. This becomes my particular equation that I can work with for future problems of this particular infection. So with this equation, I can answer the question of what would be the number of infections on day 40th. What do you put 40? Into t, right? You put 40 into t, then you can figure out the number of infections. We'll do that in a moment. Now, I'm going to take exactly the same data. I'm going to modify this a little bit, okay? Still COVID infection. Data 2. Say suppose that you have no idea how many people got infected on day 1. Say if you didn't know on day 1, but you do know that day 1 happens on a certain day, but you didn't know how many people got infected on day one, and you started catching up, and you finally got your acts together, it's already day 10. It's already day 10. And so you, as a scientist or some sort, you collected this number. At t equal to 10, the number of infection is 16. So you're still catching up. 10 days later, 16 people. That's not a whole lot. You think, that's not a big deal. The same way that someone may say, first day, only one infection, no big deal. But you also caught on. You say, well, wait a minute, after 20 days, you got 256. I want you to find a particular equation using this data. Go ahead. Find a particular equation using this data. I'll give you the answer. The answer is the same. You're going to have to come up with the same equation. But what I'm interested in is how you get here. It's going to come up with the same equation. So why don't I help you with this now? We're still using this general equation, n is equal to a to the b to the t power. So now in this case, we're going to start with a t equal to 10, n equal to 16, right? We're using this one. We're using this one. Going back to this equation. So n is equal to 16. A we don't know. B we do not know. T is equal to 10. We have A and B. Can do it. Okay. Try the next one. The logic will tell us, right? I want you to think about how I think, okay? I don't look at this problem and all of a sudden I say, I got it. I know exactly how to do this problem. I never do that. What I do is I let the equation inform me what my next decision might be. I get here and I got stuck and I say, okay, I got stuck by using one set of data. I have one more left. I can use that and see what that leads me, right? So I'm going to use the next one. T is equal to 20, n is equal to 56, and then put it back in again and see what happened. 256 is equal to a times b to the 20th power. Okay, I have equation number 1, equation number 2. I got some numbers. I got a and b. I know from previous lessons, like all the way back in the days, if you have two variables, you need two equations to solve. Okay, right?
Subtract a from the sides and then
subtract?
Yes, so if you take the two equations and you subtract a, and then
subtract
16 and 256, then you have two equations that both equal.
So you're taking equation 2, so you're saying equation 2 minus equation 1.
Or no. If you set equation 1 and equation 2 both equal to a or both equal to negative a,
okay.
You have them equal to each other, and then now you have one equation with one variable.
Got it. So you wanna basically isolate a, make a equal to 16 divided by b to the 10th power, and then you want to plug it in.
Yeah.
Substitution, right? Remember in the system equation x and y, we had two ways to solve a system equation using substitution method. Another one is using elimination method, right? Substitution method will work, will be more complicated. I'm going to suggest elimination method. Eliminate one of the variables. But here's a problem. If you have a times b to the some power, you can't subtract two equations to get one thing, because it's multiplication. So how do you get rid of things when something is multiplying? Divide. What if we do this? What if I take second equation and divide it by the first equation? Take a look at this. 256 equal to a times b to the 20 power divided by 16 divided by a divided by b to the 10 power. Right? Because isn't that the same thing? This is the second equation, this is the first equation, I just divide up and down. When I divide this, a and a cancel out. Okay, take a look at this. 256 over 16 is equal to, now a is gone. We end up with b to the 20 power over b to the 10 power. Now, if you have b to the 20 power over b to the 10 power, it is equal to b to the what? Huh? B to the 10 power, right? Right? It's division, so you subtract exponent, right? 20 minus 10, you get b to the 10 power. So you can end up with b to the 10 power. Okay, so what's b then? b is equal to 256 over 16 to the 1/10 power. Now, this is when you can use your calculator to help you. So go ahead and use your calculator. You gotta do it. If you don't do it, then you're not allowing the tactile motion to help you remember things. So put parenthesis 256 divided by 16 parenthesis to the power of parenthesis 1 over 10 parenthesis. See what you get. What do you get? What do you have? 1.319 dot dot dot. Hey, look at this. Is that the same one as this one? Okay, now we found B, we haven't found A yet. So what do we do with this in order to find A?
So you plug B into one of the equations and look at it.
That's right, you plug B into one of the equations. So you put it in here. Let me just move it over here. So you put B in here, so we can use one of those. So 16 is equal to A times B to the 10 power. So then 16 is equal to A times parenthesis 1.319 dot dot dot. If you are able to keep that long number, just using the long number. So then A is equal to 16 over 1.319 dot 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 to the 10th power. Use your calculator and figure out what that is. It should be 1. It should be 1. Give it a shot. See if it's 1. Is it? Yeah, it's 1. So your final answer, right? Your final answer is indeed n equal to 1 times 1.39 or 319 dot 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 to the t power. This is a particular equation. Now, the question next question is, what is n? What is n when t is equal to 40 days? That's easy, right? It's just using your calculator. N is equal to 1 times 1.319 to the 40th power. Your answer should be like 64,000 or 65,000, right? Something like that. I think if you just use 1.319 instead of all these decimal, you should get roughly around 64,534 infections in 40 days. That's an exponential growth. Okay? So the previous video I gave you are mostly following this type of equation, a type of situation where you can find A pretty easily. I gave you the second problem type, which is that finding A and B are not so easy. Okay? Now, we also said that in this particular case, y A times B, let me just move it over here. Y is equal to A times B to the x. A is usually the initial condition, right? And this B value is quite interesting. This B value turns out that this B can be written as 1 plus minus R. R is the rate of change. The growth rate or the decay rate. So plus means it's growing, right? If it's 1 minus the rate, will be the decaying rate. So in this case, when we look at this, initial condition is 1 because at day equal to 0, we have 1 infection. Our B value is 1.319. This means that that means 1.319 is equal to 1 plus 0.319 . So that means this one is your R value, right? That means this infection is growing at 0.319 or 31.9% daily growth rate. It's growing at a 31.9%. That's called the rate of change. Now, I'm going to give you a different example. Maybe hopefully it's a more positive example than a negative. It's a COVID infection. This one has to do with money that you save. Okay? So let me erase this. Question so far, are you following? You guys following? This is the time that you ask questions. You may not have another opportunity. The general form again, y is equal to A times B to the x. But we also can look at it as y is equal to A times 1 plus R to the x power. Obviously, this is variable. This is the initial condition. And this is rate. Okay? So, investment. This has to do with investment. Say you put your money into a index fund. Who understands what index fund is? Stock market. You understand stock market? Now, if you put money into a company stock, you have a lot of risk, right? So the company can grow, you hit a home run, make a lot of money. If the company, just go bankrupt, you lose all your money. So a lot of people decided that, a smart way of investing is if you have, $10,000, instead of investing in one company, you invest in 10 companies or 100 companies, right? The more you invest, you basically banking on the aggregate of the growth of these companies. Some gonna go bust, but some gonna be successful. And so in an aggregate, on the average, on the whole, you're gonna do pretty good. Historically, if you do that, if you invest on the entire stock market, meaning you distribute your fund evenly across all the companies, big and small and all that stuff, and lots of them, your average growth is about 10% a year. 10%. That means if you put in $100 in a year, you get $110. No, I'm sorry. Yeah, that's right, $110. And then the second year, you get another 10% from the $110 that's already grown in that market. Does that make sense? Got it, right? So if we're talking about 10% growth in overall stock market, then the rate is equal to what? Huh? 0.1. So our investment equation, we can call y is equal to a times b to the t power. T will be time, y will be money, and this will be number of years. A is initial condition. That means how much money you put in the first place. And R in this case, or B in this case, will be what? What's B value with a 10% growth? What's that? 1.1. Right? 1 plus R. 1 plus R, and R is 0.1, so it's 1.1. So here you go. You got an equation. Y is equal to A times 1.1 to the t power. We're 4 people. They have different investment strategies. Let's see. You guys will be person 1. These 2 people. You guys equal to person 2. Person 3. Person 4. Got it? Okay. Yes. You guys decided to invest $1,000 at age 15. You guys decided to invest only $500, but also only at age 15. You guys, person 3, you invest $1,000, age 15. Last person, $1,000, age 15. But person one, you decide to cash in at age 25. Person 2, you want to cash in on age 25. Person 3, you're going to cash in You're gonna hold it steady. You're gonna not be tempted to cash in. You're gonna wait till you are 45 to cash in. And then last person, you decided, oh, I'm sorry. Last person, you're a latecomer. Instead of investing at age 15, you decide to not invest, but when you turn 25, you decide to invest $1,000. And then you also decide to cash in at age 45. So go ahead, figure out how much you have at that age, at the target age. Go ahead, use your calculator. Use your calculator. See how much money you got. See how much money you have. Just write down the cost of everybody.
How many cents we get? Theo, how many cents did we get? Huh?
Samantha, what does it equal?
You guys gonna write it? You guys go ahead and write it down.
Yeah?
Good job. All right, last group. Okay, so take a look at this, right? So we know the initial condition in this case is A, right? And so it's whatever the number you start out with, age 25, right? So or age 15. So age 15 to age 25, t is equal to 10. So you put 10 into t, and then you put 1,000 into the initial condition, you end up with $2,593 plus change. The person two, in this case, the only difference is, wait, hold on a second. Oh yeah, 25 minus 15. So this could simply just, you can simply just write this as 10, right? That's 10. Okay, but that's good. That's good. You show the details. So in this case, person two, same amount of time, but investment really is cut in half in the beginning. Take a look at this. It's $1,296. So in this case, if you think about it, I mean, maybe it's another good analysis. Maybe we can even try age 45 and age 45 here and see whether it become even more of a gap. You can already see that initially, person two invests half of it, half of the person one's amount of money, but in 10 years is below half, right? In terms of the gap. So imagine 20 more years later, the gap is gonna widen. Person three, same amount of money, same time to start, but increase the length by how much? By additional 20 years, right? Additional 20 years. So waiting for 30 years. So this is 30. Just make it just for the recording so you can see better. This person ended up with $17,000, $17,449, all just sitting there. It's like not touching the money, you're not adding more money to it. You just literally $1,000 age 15 sits there, and you cash in at age 45. You end up with 14,000 more. And here, person four starts 10 years later than person three, only got $6,727. Look at that. This is the power of compound interest. Power of compound interest. Put money in, the initial amount will make a difference, but not as much as the time you allow it to grow. And it will go faster and faster and faster the more you wait. Does that make sense? What kind of conclusion can we make on this regarding your personal finance? Huh? You need to invest. You need to invest. Someone I know, I won't tell you who it is, probably too embarrassing for me to talk about, but someone I know, when she was born, her uncle gave her a $100 Apple stock. $100 Apple stock. By age 40, guess how much the Apple stock is worth right now, today? That person has turned 40 years old. 40 years. Apple stock. When she was born, the stock was one Apple stock for $100. Right now, 40 years later, guess how much that Apple stock is worth? 40. Huh? 40 what? 40,000. How many of you think is $40,000? I'll tell you. Back in 2015, when this person checked the Apple stock, right? This was $100. 2015. Went to the investment fund manager, checked the Apple stock. This particular stock was worth $70,000. That's 2015. 2022, how much is it worth? 400,000. 400,000. And this is a real story. This is no joke. $100 stock, time when you were born, at age 40, 400,000. So think about savings. Think about savings. What's that? Well, you cash in and you have to pay about 27% capital gain tax. So it's better to save it and then give it to your children. Any questions on that?